How are you? Good evening, everyone. Let you get seated for Edible Education 101, our 7th class meeting. We're just over the hump. We've got 13 total class meetings this semester. This is number 7. Thank you again for joining us. This is a photo from my garden today. This is a sempervivium, which for those of you that don't think you have a green thumb, if you can't grow this, you're out of luck. This is something that effectively you can break off and just stick in the ground and it will keep growing. So if anyone is really challenged with plants, let me know and I'll bring you one of these to grow. They're pretty remarkable, but they're beautiful at this time of year. They take on this really vivid color, and they also grow in this, what they call in the wine business, this kind of hen and chicks form, where you have the mature plant with the offspring kind of interlacing. So it's one that, in spite of all this rain, kind of brightens my day. Remember last week we talked about seeds and seeds as genetic resources. And this is a scene from my, this is a photo from my little greenhouse. Things are looking pretty good. As you know, Henry David Thoreau said, "I have great faith in a seed. Convince me that you have a seed there, and I am prepared to expect wonders." And I thought last week's presentation was really wonderful to have the complement of the journalist, the investigative journalist's perspective, combined with the entrepreneurial perspective of a startup working to change the system of supply and to actually be breeding seeds for deliciousness, and flavor, and also for their kind of integrity and harmony with a full system of farming, so that even the biomass, like when Charlotte showed us that stalk from the squash that Dan Barber makes into a penne-looking ingredient, that was just really fascinating. To me, that was real innovation. Very exciting to see. I wanted to remind you that we prefer you not to use your computers in this class, so if they're open, we'd appreciate if you'd close them and give your full attention to the speaker, our guest today. A little bit in the news, boy, a lot in the news this week. Yesterday, the Environmental Working Group put out a really incredible report showing that there are more than 2,000 chemicals that occur regularly in conventional packaged foods. So 2,000 chemicals that are for colorings, flavorings, preservatives that are not apparent or not in organic foods, and that many of them have health issues related to them. And so I wanted to just bring this up because it's very timely with Urvashi's presentation earlier in the semester about who do we trust and who's looking out for our best interests. And I think the punchline of this report was really that there's a lot more to be said for organic ingredients than meets the eye. And these arguments about organic is not going to necessarily feed the world, or there's no nutritional benefit shown to organic over conventional. There's a very strong case that these ingredients, which are not screened in the same way they are in other countries, and they're not regulated, are being found in our food supply. On top of that, this is hard to read, and I can't even read it, but I wish I could read it. But in today's New York Times, does anybody read the New York Times in this class? A couple of you? Good. So our friends at Clif Bar, who actually have their world headquarters down the street in Berkeley, took out a full-page ad in the New York Times challenging the CEO and founder of Kind Bar. Anybody had a Clif Bar? Anybody had a Kind Bar? So Clif Bar is all about organic ingredients, and Kind Bar is all about sort of nutrient-dense ingredients. And so it was really provocative that the founders of Clif Bar, Cliff, Kit, and Gary Erickson, kind of threw down the gauntlet. And what was really interesting was that this is timed to coincide with the beginning of the Natural Product Show, which starts tomorrow, which I'm going to talk to you a little bit about. But basically this said, dear Mr. Lubetsky, won't you come over to the good side and source your ingredients organically? You know, you're doing good things in the world, you're a leading brand. It doesn't mention that Mars, the big candy company, just bought a large interest in Kind. So they're kind of, it's really interesting. They're saying, we're your competitor, but we'll help you get there. If you need help sourcing organic, we'll do that. Then, I guess later in the day, Mr. Lubetsky tweeted back and said something like, Clif's approach in selling snacks made predominantly from organic brown rice syrup, which is basically sugar, isn't the solution. We'd be happy to meet and share why Kind focuses on making snacks that always lead with nutrient-dense ingredients like whole nuts, whole grains, and whole fruit instead of sugar. That is why Kind's leading snack bars have a fraction of the sugar in Clif's lineup. So here we have, this is pretty intense, right? And you know, you would say like, these are the good guys, right? These are the companies that are already sort of, you know, this isn't big food speaking. So this is pretty interesting, and you know, it puts us as eaters in the middle of this debate whether do we really have to trade off between organic and nutrient dense? You know, so I don't know, maybe we should propose they merge or something. But I was going to tell you that tomorrow, any of you that are aspiring to have a career in the healthy foods business, you got to get down to Anaheim in March and see the Natural Products Expo. This is one of the most spectacular gatherings. I mean, the only thing I can compare it to is Burning Man. 85,000 people went last year. More than 3,500 different exhibit booths, and more than 560,000 square feet of exhibit space. It's completely exhausting, but anything that claims to be organic or natural or progressive, you can find there. And it started in 1981. I started going in 1989, and frankly, it was kind of like a lot of people that, you know, were kind of hippie-like. You know, they were kind of alternative, you know, a lot of long hair, a lot of sandals. And then in the mid-90s, I remember people in suits started coming. And then in the later 90s, people from the investment community started coming. And now it's a really interesting mashup of a lot of entrepreneurial zeal and energy combined with very large companies who own a lot of the brands that you see. But again, I would really encourage you, you know, if you want to make a difference in the food business, go there. A couple years ago, Michael Pollan was asked to give the keynote at the big gathering, and he kind of took everybody to task about their ingredient panels, just saying, you know, you call this stuff natural, but boy, there's a lot of processing that goes into the foods. And as we talked about, you know, a lot of packaging waste too. This week we have a wonderful guest, a really timely topic, a tough topic that is going to challenge us to really think about how to solve or how to intervene in a system that has a lot of entrenched interests. I'm really delighted that Professor Julie Gutman's here with us tonight. I'm going to introduce her in just a minute, but she's going to talk about the fragile future of the strawberry industry, which many of you know is near and dear to California's economy and heart. As you know, the theme of this class this semester, given the urgency of the issues around climate and the role of the food and agricultural systems to intervene and make a dent in changing this really urgent climate crisis, is to take action. And Now that many of you have submitted your essay, which is due in about 5.5 hours, I noticed a few of you haven't sent it in yet, but those of you that have, you can start thinking about the next essay, because by the end of the course, we're going to ask you to start thinking about creating an action plan. So remember the first class, I showed you this model of how we follow our curiosity. We immerse ourselves, we research, we go deep, we learn from multiple perspectives, we reflect on what we're learning, we try to integrate it, and then we create an action plan. This is the kind of the entrepreneur's heroic journey. This is how ideas turn into action. They turn into businesses, they turn into projects, they turn into careers, they turn into movements. And so we're going to challenge you. I just want to plant the seed now so you have the next 6 weeks or so to think about your own personal action plan. I want you to think about how you might take action on a personal level. What might you just even change in your own eating habits that could collectively make a difference? I want you to think about the community level. What community organization might you participate in? Marion Nessel, who was here last month, she's always challenging us to find an advocacy organization that we can relate to and that we could contribute to and learn from. What about the national level? Do you want to get involved in policy? Do you want to get involved in creating regulations that really take care of people? Or maybe you want to go out and try to transform a sector. In a couple weeks, we're going to hear from people that are trying to transform the meat sector and the vertical farming sectors by bringing technological innovations. Or maybe you even want to play a role on the global scale. So I want you to think about where you might participate in the system, and you might think about different ways that you can be involved. But in a couple weeks, we're going to give you the prompt for the second essay. And it's really going to be about you developing some experience and confidence and clarity about what you're going to take from this class and apply. Okay, so it's not going to be just an academic exercise. It's really, if you're a business major, this is your chance to write your own business plan. If you're studying environmental economics, this is where you can start to apply. So even think about in your other classes, your other aims of study, how you might integrate them with our goals in this class. So for those of you that read the papers, the pre-reading, you noticed that there were a lot of pieces to this puzzle about the strawberry industry. And the strawberry industry, I think we're going to learn, is representative of a number of other aspects. And what struck me, I was looking for an image, Julie, about like, how do you mesh? What is the art of meshing these very diverse perspectives, self-interests, competing kind of paradigms and economic incentives? And I think that the tensions that are illustrated in the case study that we're going to hear about tonight are really at the heart. These tensions, and just even the tension I just shared with you around nutrient dense versus organic. There's just so many trade-offs and choices, and we've built a system and we participate in a system which really is not fit for the next 20, 30, 50, 100 years. So without further ado, I would like to introduce to you Professor Julie Gutman. She comes from the University of California at Santa Cruz. She's an alumna of University of California at Berkeley and even got her MBA at the Haas School of Business. So I love when we meet people that, again, are cross-pollinating the world of business, the world of social science, the world of agroecology. She brings really a diverse set of interests, and when we get to sit down over there, I'm going to ask you like how you put all that together. But let's have a warm welcome for Julie Gutman. Thank you. Oh, thank you.
Well, thank you. Thank you for inviting me here. I'm really delighted to be part of this edible education that's been going on for a while. So today, first I'm going to figure out how to use the clicker. What's that? Okay, I'm not, okay, I'll use, sorry.
Oh, this one.
Oh, okay, it's whited out, okay. Okay, it's worn out. Okay, so today I'm going to talk about my most recent research, well, not my most recent research, but some very recent research on the California strawberry industry. As it happens, I've just completed a book and it'll be out this summer. You're the first to see this kind of really strange cover. I'd be curious to know what you think about it. I'm not sure how I think about it, but it is jarring, and probably my talk might be a little so as well. So I thought it might be useful to say a few words about how I landed on this particular research project, because it's very much in keeping with the course theme on taking action. So I've long been fascinated with the strawberry industry for reasons I hope will come clear, but my interest in strawberries was reignited about 8 years ago. And what took place then was a spate of activism around the registration of the chemical methyl iodide. Methyl iodide was promoted to be a replacement for methyl bromide, which was being taken off, which was being regulated away because of the International Treaty on Ozone-depleting substances. And methyl iodide was going to replace methyl bromide, or the strawberry growers hoped it would, as a soil fumigant. You'll hear more about the need for soil fumigants, but methyl iodide is a highly toxic chemical, and it's used to control soil pathogens and nematodes, which are tiny little worms, and weeds. But methyl iodide was far more toxic than methyl bromide, which is toxic too, but the main problem with methyl bromide is it will go into the stratosphere. But methyl iodide was associated with birth defects and cancers, and it's used to actually induce cancer in laboratory rats, so it's a really nasty chemical. So I was intrigued by the battle against methyl iodide because for the first time I can remember foodie activists were joining public health, environmental, anti-pesticide groups, and farm worker groups in opposing registration of the chemical. And I have had a long-standing critique of the food movement's focus on voting with your fork as a way of affecting change. So I was intrigued to see the movement pursue what I call a more oppositional strategy. Long story short, the activism scared growers out of adopting the chemical, and following a lawsuit that was brought forward by Earth Justice, the company that owns the chemical took it off the market. They took it off the market because they didn't think it would be economically viable. So this was heralded as a major anti-pesticide and food movement achievement. And since then, the industry has seen tighter regulations on other fumigants it's used to replace methyl bromide. So I set out to research what growers were doing in the face of these tighter restrictions on these fumigants that have been really so formative in making the strawberry industry successful. So in the course of visiting farms and talking to growers to learn about these questions, I found a complex and deeply entrenched web of connections in the strawberry production system. And these connections reflect the multiple ways that the California strawberry industry has co-evolved with the plants, soils, chemicals, climate, and other non-humans that constitute the conditions of strawberry production. So this evening, I want to give you a glimpse into this coevolution and why it's so hard for the industry to do without soil fumigants. Now, you might already be asking why the strawberry industry merits so much attention. Well, for one, strawberries are big business in California. They are the 6th highest grossing crop in the state. Their production dominates the agricultural landscapes of several coastal counties. And today, California supplies nearly 90% of the US strawberries and about 20% of the world's. And with the exception of raspberries, they are also significant for the value they produce on a per acre basis. So these days, growers typically gross nearly $70,000 per acre, making a 15-acre farm $1 million venture. That's kind of unheard of in most agricultural production. They also put a lot of money into it too, and that's significant. Strawberries are, of course, of interest to consumers. Nutritionists rarely agree on anything these days, but one thing they tend to agree upon is that fresh fruits and vegetables should be the center of our diets. Berries are particularly virtuous. They're not high in glucose. They're chock full of essential vitamins, minerals, fiber, and antioxidants. And parents love them because their kids will eat them. And strawberries have been heavily marketed. Per capita consumption of fresh strawberries in the US almost doubled between 1994 and 2014, in large part because of the efforts of the California Strawberry Commission in promoting them. Still, my reason to talk about strawberries is not to boast about the economic importance and health benefits of this crop. It's to show how the very features that once made strawberry production so lucrative in the Golden State now pose grave threats to that very industry. So just a quick slide of the maps. The map on your left is, well, the map on your right is just, a map of California with main features. The map on the left are the main strawberry growing regions in California. Those dots are where some strawberries are grown, but the fruit growing regions are mainly in those 4 coastal counties of Monterey, Santa Cruz, Santa Barbara, and Ventura, with more and more in San Luis Obispo. And that's because strawberries really thrive well with the cool ocean breezes coming off the Pacific Ocean. In the far north of the state, those production regions are where there are strawberry nurseries, where you'll hear a little bit about. So I want to begin the meat of this talk with this photo. And this was taken at an interview I did with a grower in Santa Maria, California, which is one of the major strawberry fruit growing regions. So in the foreground of the photo is a buffer zone where this grower wasn't allowed to fumigate because his farm was too close to a school. Although the grower hadn't yet tested the soil, he suspected that what was causing that damage in the front part was a soil pathogen called Femina, Alena, which is a fairly new pathogen in California. So Femina has been showing up in fields since growers stopped using methyl bromide, and it's even appearing in fields where they're using alternate fumigant chemicals. So together, Femina with another novel pathogen, Fusarium oxysporum, along with one that's been around for a long time, Verticillium dahliae, pose a major, even existential threat to the strawberry industry. So how did the situation come to be? Well, strawberries were well established in California before Verticillium dahliae was identified as one of several diseases afflicting California's strawberry plants. By 1920, growers were noticing that plants were consistently wilting and often dying. They called the problem brown blight, and they turned to the University of California here at Berkeley, to ask for support. The newly arrived Dr. Harold Thomas of the Berkeley Plant Pathology Department was put to the task of identifying the problem. And he observed a striking correlation between brown blight on strawberries and land that had been previously cropped in tomatoes. So he conducted a series of experiments and determined that the causal agent was indeed belonging to the Verticillium family, which is a family of fungi. Now, in strawberries, symptoms of Verticillium wilt appear well after planting. The cause of the wilt is a vascular infection, meaning that the fungus colonized the root tissue of the strawberry or of the plant, and once inside these tissues, it spreads to the taproot and plugs it, preventing the plant from uptaking water and nutrients. And the remains of the fungus last in the soil for 14 to 15 years, even in the absence of a host. So it can reappear far down the road. So by the 1930s, verticillium wilt had become a major production problem for the strawberry industry, with plantations established in infested soils often suffering 50% or more mortality. And strawberries that followed tomato, potato, and cotton crops fared particularly poorly. Now, to address verticillium dahliae, along with other diseases in strawberries, UC set up a public breeding program under the leadership of this same Dr. Thomas. The breeding program built on the tremendous genetic possibilities of the strawberry. The cultivated strawberry is a hybrid of two highly variable species, which allows nearly infinite variation in breeding. These possibilities notwithstanding, few varieties were developed to be resistant of pathogens. Instead, breeders focused on productivity, and two of these varieties developed by UC were responsible for a tremendous expansion in acreage, yield, production, and farm value. And these were a bunch were released in 1945. These are a photo of beach strawberries. I say this because one of the native species in California was one of the is very closely related to one of the native species in the hybrid strawberry. And these, if they could find more wild strawberries now, it might be of use, and I'll explain why later. So other breeders, public and private, used the genetic advantages of the strawberry to develop varieties that could lengthen the strawberry season and take advantage of the mild climate of coastal California. Elsewhere in the country, strawberries are a 3-week crop. But when you have those ocean breezes coming up off the Pacific Ocean, you can have strawberries in the ground for 9 or 10 months a year, and they still think it's spring because of the foggy weather that I know you're all accustomed to if you're from California on the coast. So they created short day varieties that could produce in late winter and early spring, and they created day neutral varieties that would bear berries over extended periods and well into the fall. And together these could be grown in different regions of the state, enabling the shippers, if not the individual growers, to supply strawberries nearly year-round in the market. They also bred for shelf life, so it could be shipped. They bred for size. They bred for color. And occasionally they even bred for taste, but not so often. The Albion strawberry is one of their best tasting varieties. It's mainly used for by farmer market growers. So all those other qualities could allow this long distance shipment, and the color and size and shape was supposedly attractive to consumers. The extension of the producing season was further enabled by the spatial separation of fields and nurseries. This is a high elevation nursery in McDowell, California, which is in the very far north of the state, northeast, and it's very cold. It starts getting really cold in October, which actually tricks the strawberry into dormancy, so then they replant it in the Southern California a couple weeks later. It thinks it's spring. So the initial purpose of these nurseries was to separate the new seedlings from diseased soils, but they found that this winter chilling and dormancy allowed them to extend production even more. So in the 1960s, most of the major nurseries relocated to these high altitude places, high elevation locations where they remain today. Now, without pathogen-resistant varieties, for a long time, strawberry growers addressed the pathogen problem simply by moving to new ground. So this practice relied on the availability of land suitable for strawberry production, the well-drained sandy soils prevalent on the temperate coast. Now, land was readily available for a while because many former farmers in the prime coastal regions had ceased farming and were leasing out land to others instead. They decided it was more lucrative to farm farmers than to do their actual farming. That's why, one of the reasons why most agricultural land in California is leased. Now, scientists recognize the dangers of growers just leasing out any land. They told growers to avoid land that had been previously planted in tomatoes, potatoes, and lettuce, since all were hosts of the pathogen Verticillium dahliae. Knowing that weeds could be refuges for the pathogens, they also encouraged growers to weed their fields carefully. And growers also had to be weaned off the practice of leaving strawberries in the ground for several years. A practice was encouraged as early as like 1793. So in 1955, a UC pomologist suggested that growers replant their strawberries annually. But few growers took his advice seriously until a disastrous year in 1957, after which about 21,000 acres in production dwindled to 9,000. So annual planting helped somewhat, but the problem of producing a healthy strawberry plant free of wilt seemed to have been resolved for once and for all with the introduction of soil fumigation, with a combination of two chemicals, chloropicrin and methylbromide. Now, chloropicrin was basically tear gas, and it had been used prodigiously during World War I. The chemical causes vomiting when inhaled, and so soldiers would with gas masks on, would remove their gas masks so they would, to vomit, and then they would be exposed to the full spectrum of lethal gases. So chloropicrin was basically used as an agent of war. But nevertheless, in 1953, UC scientists began experimenting with chloropicrin on strawberry land. That they found that the fumigation with chloropicrin not only controlled the pathogen, but also somehow made the plant more responsive and vigorous. A 1956 research article in California Agriculture, which is the magazine of UC's agricultural extension, declared verticillium wilt controlled. Soon after, these same scientists began experimenting with a combination of chloropicrin and methylbromide. Methylbromide had first been synthesized in the 1880s. It was first used as a fire retardant and then later as a fumigant for food storage, and then it was also used to delouse the troops during World War II. And the first experimental results of combining methylbromide and chloropicrin indicated that methylbromide not only augmented the fungicidal properties of chloropicrin, but it also gave excellent weed and nematode control. So eventually, research scientists were able to determine that chloropicrin carried the load in terms of the suppressive action on fungi, but methylbromide had a very high vapor pressure that could distribute the two chemicals throughout the soil and through just about everything. It could just blast it through soil. And also, methylbromide lacked any distinctive odor. So if there's some reason that there was too much fumigated, people wouldn't be able to detect it. But chloropicrin really stinks. And so they also, and it causes tearing. So they used a little bit of chloropicrin with the methylbromide, and it would act as a warning agent that the chemical was drifting. So the big news is with fumigation, growers could now stay on the same ground and plant year after year. And so by the end of the 1960s, growers had widely adopted this practice of fumigating with the two chemicals. There was another important ingredient of the strawberry industry's success, seemingly unrelated: forms of labor control that encouraged care and ensured loyalty. Now, the importance of labor control lies with the enormous capital outlays of strawberry production, much for land preparation, including fumigation. And since these non-labor costs are fixed and must be made up front, growers invest a tremendous amount of capital per acre before one strawberry is picked. So in a general sense, the political construction of farm labor markets to create both labor surplus and non-citizen status have been the central mechanisms to control costs and ensure loyalty. Undocumented workers are particularly reluctant to report wage theft or pesticide use violations. In addition, growers incentivize productivity by paying harvest workers largely on piece rate, allowing growers to make more money in a short amount of time. Now, I had a video to show you, but it didn't make it here, but I have a video that I took very recently that shows workers racing through the fields to pick strawberries. They pick like this fast and they run because they're paying on piece rates. They can make more money the faster they go. And so a very skilled worker, so you've seen those crates of strawberries in the supermarket where there's 12 baskets in a crate. A very skilled worker will pick about 9 of those in an hour. And that's how he or she, but generally the men tend to work at that rate, can make maybe a decent hourly wage, probably, something above minimum. And the workers that can't pick at least 6 get fired. Breeding for strawberries that are large and visible and easy to remove also allowed workers to pick quickly, and that also reduced per unit labor costs. For that matter, so did fumigation, because fumigation was ensuring that there were abundant berries on the vine. So fumigation was actually helping workers. They weren't exposed necessarily to the fumigants, but they would get more, there'd be more in a plant and they could pick them rapidly. So together, plant breeding, fumigation, land availability, and labor control made for a highly profitable strawberry industry in California. And the industry saw huge increases in acreage, yield, and crop value between 1967 and 2004. Acres in production grew from 8,000 to 32,000, and yields per acre increased more than 5-fold. So one would be hard-pressed to find anything in the scientific literature of the day that did not herald fumigation as the salvation of the strawberry industry. All seemed well until the novel plant collapse problems associated with macrofemina and fusarium that appeared in the mid-2000s, precisely when methyl bromide was starting to be phased out. All of a sudden, these advantages were morphing into threats. So I want to talk about some of the current threats to the strawberry industry. Here, I'm going to take this off. And one has to do with privatization of the breeding apparatus. So again, success in breeding really built on the incredible genetic variation of the strawberry, of ancient varieties, I should say. And that allowed plant breeders to develop attractive and sturdy and somewhat tasty varieties that can be grown in various regions. University of California was running the major breeding program. And so growers were able to obtain these strawberries from the University of California at relatively low costs. But some strawberry growers, shippers, and breeders recognized the competitive advantages of keeping prize varieties to themselves. So they developed their own private breeding facilities, and this included the Strawberry Institute, which was created in 1944 by Driscoll's. And shrewdly, Driscoll's wooed 2 sciences that founded UC's breeding program and took them over to Driscoll's private institute. And it is alleged that they took much of the genetic stock with them as well, giving Driscoll's quite a head start. Many years later, quite recently in fact, 2 other UC plant breeders left the university to form their own company and walked off with germplasm in addition to their own knowledge. And the Strawberry Commission, the California Strawberry Commission, sued University of California for that. And since then, that's a long, ugly story, but since then UC has actually reinvigorated its breeding program. But in addition, UC is itself becoming more proprietary about the varietals it develops. And that means higher royalties for growers. And growers operate on very thin margins. And this sequestering of knowledge and germplasm is not insignificant for the emerging imperative to develop pathogen-resistant varieties, because some have suggested that a long history of breeding for productivity has narrowed the base of the germplasm, and it may take going back to these ancient varieties, like those wild strawberries you saw on the coast, to recover traits that might be usable for pathogen resistance. And it's not clear that whether those ancient varieties are still publicly available. So that's a big threat to the strawberry industry, particularly low resource growers, I should say. A second major threat is, of course, heightened restrictions on these fumigants. Really, the strawberry industry really developed on the basis of soil fumigation. And for growers, fumigation is like a form of crop insurance, they say. But recently, the primary fumigants have seen tighter restrictions owing to their environmental and public health effects. After years of the efforts, U.S. tried to forestall the inevitable when methyl bromide was declared a ozone-depleting chemical. For years, U.S. got some what are called critical use exemptions, but those were phased out. And so right now, growers cannot use methyl bromide, except the nurseries can still use it. Methyl iodide was designed to replace methyl bromide, was, as you heard, taken off the market following that regulatory battle. And chloropicrin, which is the most widely used fumigant, the one that causes vomiting and tear gas, that was designated a toxic air contaminant for its respiratory effects, and now is seeing much more restricted use, including bigger buffer zones between strawberry fields and nearby housing or nearby workplaces or schools and hospitals. Sandy soils and the temperate climate of the California Central Coast were other important ingredients of success. The latter allowing a lengthy harvest season that worked well with these innovations in breeding. And as we saw, having abundant available land allowed growers to abandon acreage when disease broke out. The problem now is that suburbanites enjoy the same natural air conditioning of the Pacific Ocean that strawberries do. And so suburban encroachment has really reduced the stock of strawberry land and also jacked up the prices of strawberry land. That's taken in Oxnard, California. I don't know if anybody's from that area, but you see strawberry acreage coming right up against strip malls and shopping malls and housing developments. In addition, as more housing and schools and workplaces abut strawberry fields, there have been more demands for stronger fumigant regulations, notably to protect neighbors more than workers. Because these are like kind of working and middle-class homes going in, and they don't want to have pesticide drift by them either. We've also seen a lot of land grabbing of, or otherwise known as agricultural investment. And we've seen a lot of bidding wars over both leases and sales of land suitable for strawberries, especially land with high-quality water sources. More generally, agricultural land values tend to be based on the most agricultural yield that you can get from that. So if you're growing a high-value crop, and you're growing it on an annual basis like you do with strawberry, the land value, even if without suburban encroachment is going to be based on the expectation that you can continue selling that crop at that price with that kind of yield. Staying in business on such land requires that continued high yield, and that could only be achieved with fumigants and varieties bred for productivity. If you don't fumigate and you rotate instead, you won't be able to get as much value out of that piece of land. And then there's a labor shortage. Now, for a long time, U.S. immigration policy served the industry well. The border was porous enough to allow the production of labor surpluses, and that, along with undocumented status, suppressed worker wages and kept workers compliant. But in the past 20 years, fortification and militarization of the border has made it much more difficult and costly to cross. That, with the growth in construction and better farm jobs and entry-level back-breaking strawberry work, has created a major labor shortage of harvest workers. And growers complain bitterly of this labor shortage. They complain about it more than they complain about the loss of fumigation. Growers complain about everything, but they really, they like to whine, but they really complain about the labor shortage. They talk of workers walking off the job, inspecting their fields before taking the job, getting on their cell phones to tell their friends that, hey, they're paying better piece rates over here than there, or there's more strawberries on the vines here. They talk of recruiting difficulties at the tail ends of the season. The ends of the season that breeding was strawberries was encouraged, like you could have strawberries that would last till the very end. And growers even justify the use of fumigation, saying it creates these plants that are robust and plentiful enough to attract workers. Now, there's much to say about whether labor shortages are manufactured, but hundreds of acres have remained unharvested for lack of workers. And I was hearing these complaints before Trump became president, and we know that the labor shortages are worse because people are understandably really scared to cross. And then there's the major threat of these novel pathogens. This one's a field of Macrofemina infestation. Now, most observers within the industry attribute the outbreaks of these novel pathogens to the end of methyl bromide use, as well as changes in fumigation regimes that I'm not going to go into. Yet there's others that think there's more to it. And they ask, how did these novel pathogens appear in the first place? Now, there's some evidence that they were introduced, presumably after growers had already begun fumigating, which sounds a little strange. Yet some scientists posit that these fungi were present all along, part of the soil fabric, but it escaped detection until recently. And the question is, what caused them to emerge? So the other major theory is that the plants have become increasingly stressed, while the fungi do particularly well in the abiotic conditions that stress the plants. So researchers have found that the disease from both of these novel pathogens is often more severe if the infected plant is subject to weather extremes, water shortages, poor soil conditions, including salinity, precisely the conditions that California was seeing in the 2010s until this amazingly rainy year we're having this year. So yeah, the 5 hottest years on record were the last 5, really stressing these plants. Interestingly, the scientists have also found that these infections, fungal infections, are more severe when the plant carries a heavy fruit load. So this is kind of ironic because they've bred for productivity, and yet now the heavy fruit load is actually threatening the plant. But there are a lot of other possible reasons for these diseases that are really outside of the scope of current agricultural research, but are very much in the forefront of ideas that are being generated in integrative biology. And they could be factors as well. So it could be that there's some gene exchange going on between, these fungi that have been there all along are exchanging genes from more virulent pathogens. It's possible that this virulence has worsened through epigenetic changes. So methylation processes that have made the strawberries more vulnerable or the fungi more determined. It's possible that the plants changing and highly variable microbiomes have made the plants more susceptible. And it's possible that the scorched earth approach of fumigation promoted these genetic, epigenetic, or microbiomatic changes. I mean, what I'm suggesting here is that when you have a fumigation that wipes out so much of what the plant's surroundings in the microbiome, or could be causing epigenetic changes through interfering with the DNA of the plant, those could be causing these things too. And these kind of ideas are just beginning to get attention. But if these are at all true, that it's possible that the novel pathogens are appearing from too much fumigation rather than too little. So then the question is why are these suppositions not only unknown, but really unexamined? And I want to suggest that much of this science remains undone because of the nature of agricultural science. So once these fungi became pathogens, they were studied largely by plant pathologists whose function was not to understand their coevolution, but to manage these fungi on behalf of the industry. And once chemical fumigation became the way to manage them, understandings of complexity became unimportant. So writing on German soil science in the early part of the 20th century, a historian of science, Frank Ukoder, argues that very thing. He talked about how the availability of easy fixes, such as agricultural chemicals, made unnecessary and even wasteful, more time-consuming investigations of complex ecological relations that would inevitably yield less definitive answers. He says that ignorance became a strength for farmers who wanted easy answers and scientists who saw farmers as their clientele. And up until recently, that's been the case for strawberries. Knowledge that supports alternative explanations for pathogen emergence was not produced or circulated because it wasn't useful to an industry that became wedded to fumigation. As one of my informants said, you don't need to know the biology if you can kill it. But unfortunately for the strawberry industry, that no longer seems the case. And this lack of knowledge is just another real threat. So what future? Where is all this going to lead? Most agree that the strawberry industry cannot or will not continue as it currently exists. And at the very least, there will be a major shakeout of growers. But what direction will it go? Already some are staying the course and continuing to rely on available fumigants, or they're hoping for efficacious drop-in replacements, the chemicals that, or maybe less toxic chemicals that act a lot like the existing ones. If they find them, and so far none have been allowed in California, they'll still have to pay more for them, and they won't be as effective. And so the most likely case is that strawberry prices would rise considerably. Some growers would welcome that, but some will lose out. Other growers are overlapping growers are experimenting with non-chemical modes of soil disinfestation. One is called anaerobic soil disinfestation, and it means adding a major carbon source to the fields and then flooding the fields with water and then covering it in plastic. Almost all strawberries are covered in plastic. So ASD, as its acronym, involves no toxic chemicals, but relies heavily on water in a drought-scourged state and carbon sources such as rice bran that may well be produced under chemical conditions. An entirely different direction is moving toward high-tech, controlled environment agriculture, or vertical farming, indoor vertical farming, or some variations of that. At the very least, it involves they're doing it outdoors right now, and what they'll do is plant berries in trays of soil as substrate, so that takes soil away from this altogether. So they'll use like coconut coir or peat moss. The approach is not without merits. In such systems, harvest workers can stand while picking, making the work routines much closer to desirable farm jobs, so workers don't have to be bent over picking. The problem for California strawberry growers is that this approach undercuts their most important competitive advantages, which is the sandy soils and temperate climates. Because if the industry was to fully go in this direction and go into controlled environment agriculture, there's no reason to plant strawberries in California with the high land values. You would move strawberry production close to the big urban markets on the East Coast, in Boston and New York. And so already there's a lot of greenhouse operations in New Jersey. So that may be a good approach ecologically, but not good for California growers. And then there's a truly integrative approach. This involves not only rotating strawberries with cover crops, compost, and mustard, but integrating several non-strawberry crops on annual rotations. Broccoli is a favorite since it has mild fumigation properties. But in these systems, strawberries is a minor crop, and were it to be widely adopted, parents would have to cajole their children into eating their broccoli if they were to get their strawberries. And moreover, this approach simply cannot be done in areas where land values are based on the expectations of yields that only come with annual fumigation. In short, the challenges the strawberry industry faces are not just technical. They are political economic, they are ecological, and they are scientific. But one thing is for sure, it's nearly impossible to foresee a strawberry assemblage or strawberry industry in which there won't be winners and losers. So there may be strawberries in our future, but the question is who and what will pay the cost. So I'm going to end there and thank you and acknowledge many of the funders and people who've helped me with my thinking on this.
Thank you.
Sure.
We're going to sit over here.
Okay.
We're going to take, we really appreciated your mid-course suggestions, so we're going to just give you a second to stand up and stretch. 30 seconds to take a deep breath.
Okay.
Thank you. So, Julie, I'm really looking forward to your book coming out this summer, and with the blue strawberry on the cover. And like when I read this book, is there like a hero or a happy ending, or am I just going to be bummed out? I mean,
you'll be bummed out.
I'm going to be bummed out.
Yeah. There's no happy ending. I mean, it has a happy start. The happy start, I start with the Battle of Methyl Iodide that I started with this with today, and I think that's important because you know, when growers see my talk or the strawberry industry sees my talk, they'll be angry with me. But the fact of the matter is that growers are moved by tighter regulation. When I did my original research on organic agriculture, which I did about 20 years ago, and when I did this research in the last few years, if growers are worried about not having access to particular chemicals, they're going to figure out ways to grow strawberries differently. So, to take action, we need to put pressure on our regulatory agencies to seriously look at the health effects of the agricultural chemicals we use and take those off the market that are just too toxic.
Where does California or the United States sit relative to other countries with the banning of these chemicals? Or have we been using them much longer? Or
U.S. pesticide regulation is a lot less developed than the EU.
I mean, so when did the EU ban methyl bromide?
Well, the original ban on methyl bromide was 2005, and the U.S. got these critical use extensions till 2015. Europe also bans chlorpyrifos. I mean, a lot of different chemicals Europe doesn't accept. California uses many pesticides because we grow specialty crops and they're delicate. And they need to look good. Strawberries are the highest, most intensive chemical regime of any crop in California. I will say though that there's some, our current head of the Department of Pesticide Regulation, Brian Leahy, is a former organic farmer, and is taking a more, I mean, he has to work with growers too, but he's been much more he's being more careful on what he's allowing. He's, you know, he really wants to take the science seriously. But this whole methyl iodide fiasco happened under the former head of DPR, who was much more sympathetic to the chemical industry. So Brian Leahy, I think, is really trying to, like, he hasn't allowed any of these substitute chemicals to come in. Like Florida is using these other supposedly less toxic replacements, and they haven't been allowed yet in California.
The other thing that comes out
Yeah.
in your research to me that, you know, sort of, I guess, bursts my bubble a little bit about the great intent of the University of California to be, you know, an agent for goodness and justice.
Yeah.
I can imagine this is going to kind of open some Pandora's boxes.
No doubt.
I mean, when you were describing, you know, the scientists obviously earnestly trying to fix this problem, I'm just wondering, like, where are the, like, public health scientists and medical people, like, wandering across campus saying, you're going to use what? You know, these gases that were used to kill people, to put on foods that we're going to eat. I mean, where's the sort of moral debate in these kinds of decisions, or what did you find?
Well, the university scientists are really interesting because they're aware of some of the public health things, but they have to work with growers. That's who they see as their clientele. Now, I'm on a project right now that's been pretty fascinating. It's run out of Davis, and it's breeding for pathogen resistance, which is a big imperative right now. And so I've gone to a few field days and observed the scientists working with their clientele, and it's funny because for instance, the scientists will say, well, I know you guys want productivity, and yet productivity is one of the things that's undercutting farmers' prices. So I think the scientists they have to do their job. They want to make the growers happy too. So I think, now some of them are much more cautious, but some of them are, you know, promote the pesticides. I mean, and they don't, I think, you know, and I mean, one of the issues is that the extension scientists are very narrowly trained. They're not working with the integrative biologists who are looking at, you know, at microbiomatics or epigenetics or all these other kind of, you know, they're not necessarily interested in the evolution of these pathogens. Like I was asking, how do these things appear? Were they there along? And they don't know. I mean, they're not hostile to the question, but they just don't have it's not within their bandwidth to think about it.
One of the goals of this class is really to be as interdisciplinary, cross-disciplinary, broad. We're always trying to make connections. I mean, we had Dr. Daphne Miller here earlier in the year talking about the soil biome and its relationship to human health. I mean, a lot of the things you're saying here are reinforcing her, some of her research and hypotheses. Do you know, if you were to recommend to this group of undergraduates and graduate students, like you're going to college now, you're talking about integrative biology, what other subjects would you recommend people study? You know, how would you go about getting prepared to lead the way in, you know, this kind of integrative thinking that's necessary to get these different, you know, areas of expertise together to, because I didn't hear, you know, here we've got methyl bromide, which is an ozone depleting chemical, but I don't hear anybody around the table worrying about that. You know, and now we're in this urgent climate crisis. So. Right.
Well, methyl bromide's, well, it's still used in the nurseries, but it's no longer allowed. Yeah. I mean, I don't know. I think I never get asked that question. I'm a big promoter of social science. I just think it's the most integrative, and I'm a geographer, and Berkeley has a great geography department, so you should all be geographers. Short of that, I mean, I think the issue here is how to have true interdisciplinary science. And, you know, I'm on this research team, and I've talked to several other social scientists on research teams, and it's really hard, actually, to have the discussions that would make social science insights relevant for scientists. We operate in different sorts of worlds. And so I think, like, working on a team like, you know, like this team working with, I think the interest is like what, I'm asking growers about what their concerns are, what kind of cultivars they'd adopt, what's their priorities in breeding, and that's useful to their breeding process. But that's not the full kind of full spectrum of things I could offer as a social scientist. So I would just say, if you're going to work in any kind of science, social science or humanities or arts or whatever, it's like the key is to have conversations across the disciplines.
Well, what led you to go to business school after? Did you do the business school after getting your PhD?
No. This I'm on my third career.
Okay.
I can give you the life story, but I'll try to make it short. I graduated from college as a sociology major from UC Santa Cruz, and I went out and did community organizing for a while, and ended up being like I had done bookkeeping in college, so I ended up being like doing the bookkeeping or the accounting, and then I ended up thinking, well, I wanted to go. I'd been working temp job because we were paying ourselves like $100 a week. It was ridiculous.
So you were subsidizing the community organizing by being a bookkeeper?
No, the bookkeeping was in high school.
Oh, okay.
But I said, well, I need to get another skill set, and I can, I was working as a temporary accountant, and I said, well, I might as well just go get a business degree and work in the nonprofit industry, because that's what I wanted to do that was related to my organizing. And I did that. I went and got the business degree and had a couple very good jobs for nonprofit jobs, and I just got really interested at that point in the developing world. I started doing a lot of travel, and I said, I just want to do something really different. And then learned about this geography department. I applied to other geography departments and got in, but I just was like, so I came to this geography department here at Berkeley, planning on working on environment and development in Nepal. And very long story short, I took a course on agro-food systems, and my advisor, who's ever heard of Michael Watts, he was a very famous scholar here at Berkeley, he had us in this course, he had us do group projects where we all had to follow some world commodity, and a group of three of us said, well, can we do something else? Can we look at salad mix in California, like organic salad mix? This was in the mid-90s, and all of a sudden you were seeing salad mix showing up in grocery stores at like $14, $16 a pound. We go, we're really curious about that. And he goes, yeah, you should do that. And so we ended up doing this small research project to try to understand who was getting involved in growing organic salad mix at a time, and found all sorts of, interest by, big corporate agribusiness. And so we ended up writing a seminar paper that was published in a rural sociology journal. Is now like one of the most widely cited things on organics. So I ended up doing my dissertation on organics. The rest is, then that got me a job at Santa Cruz, and I've been doing studies on food and agriculture since. What was the question?
Oh, I'm just really interested in non-traditional paths.
Yeah, mine's non-traditional.
Which I think is fascinating, and I think it's sort of a call. I look at the way the university's organized. It took us a bit of work just to get this class, because it's in the business school, open to other departments in the school. We're really trying to work hard to show that, to solve the problems that we've got today is going to take all of these different expertise. It can't just be done by, one area of focus, and I think your work really shows that. We've got some great questions from some of the students, and there were a lot of questions related to your the one paper that you sent to us that talked a lot about vertical agriculture and soilless agriculture and ag tech, and I think I'm just going to read one of these questions because the person that wrote it isn't here, wasn't able to come tonight, but she says, hydroponic systems seem like a promising ag technology as traditional farming begins the process of converting from chemically intensive to organic and soil regenerative methods. After learning about Row 7 seeds last week from Charlotte Douglas, and the incredible work their team has done to breed for flavor, is it possible to overcome some of the quality challenges in growing hydroponic crops, i.e. strawberries' sweetness and firmness that go missing, quote? Would breeding for quality in hydroponic systems be a viable way to make hydroponic crops more desirable and nutritious by growers and eaters?
Well, I can't speak to the science of what it would take to breed a sweet and firm hydroponic strawberry. But you know, I'm fascinated by hydroponics, but I think or all indoor farming, but I think it's controversial. Now, one thing I want to say, and it was in the article, the organic community, the die-hard organic growers are very opposed to hydroponics because for them, organics was all about a philosophy of the soil, and to remove soil from it makes no sense to them. But right now, it's allowable to use have hydroponic organics because organics has become redefined as being pesticide-free, which isn't exactly true, but that's how people imagine it, and so it's lost its kind of connection to the soil, even though there's still people trying to fight that fight, and regenerative agriculture is like one of the ways in which organics is being remade. It's like, we really meant the soil. Now, hydroponics, I mean, sure, maybe you can grow a strawberry without soil. There's some important questions. One is the cost of doing so. The infrastructure of hydroponics is tremendous, right? And so I'm really concerned about some of the social justice concerns. And one of the things that I'm really concerned about is like there's a lot of Latinx growers who are new to farming, who are former farm workers or former foremen who now have their own farms. They're completely in debt. They're the ones that are going to be squeezed out by this kind of move because they can't possibly afford the kind of infrastructure of hydroponics. So hydroponics is at the very least highly capitalized, and so that's just going to squeeze certain growers out of it, and that's how business works, we can say, but that concerns me. But there's questions also about having a hydroponic operation. I mean, if an agroecological approach is about biodiversity and including kind of all these controls, I mean, having all sorts of lively organisms there that control each other. Hydroponics is kind of the opposite. It's like the idea is almost like a sterile environment. You take away all the possible things that could hurt the plant you're trying to grow, and it's completely different philosophy, but one little bug gets in, and then you don't have all the biodiversity to help to fight that. So, you know, there have been hydroponic operations that have had complete wipeout by disease because, you know, you're trying to nurture and protect this plant from all sorts of other organisms. Complete opposite kind of philosophy of a true agroecological. So I think there's big risks for disease. And then I guess the third thing I think that's worth watching out for is, like, I think we imagine, you know, maybe you drive through the strawberry fields in Salinas or Watsonville, you say, wow, this is a lot of land of strawberries, or there's so much plastic, or whatever concerns you might have about it ecologically. But to grow the same amount of strawberries as we grow on the Central Coast hydroponically, I mean, those fields wouldn't be those fields with plastic. Those would be like, you know, huge, huge greenhouses. I mean, I think for so many of the ideas around tech, that when you start thinking about scaling up and producing the same amount of food we produce now in land, we'd have landscapes of buildings. Yeah. Yeah. We wouldn't even have the quasi-bucolic landscapes that we have today. Yeah,
we've responded to your interests, and in April we're having sort of an innovators panel here with different entrepreneurs, and I think we've confirmed the CEO of Plenty to come speak with us. So you mentioned them, so that'll be interesting. Yeah. We'll get to kind of put these questions to him. Yeah. It reminds me back when you were studying the salad greens in the mid-90s, I was actually working at a fresh juice company called Odwalla. Right. And I think if I'd heard your presentation, I would have introduced a strawberry broccoli smoothie. but
why ruin
you're
a smoothie?
cringing, but you know, but I think that it's just so interesting because so much of the strawberry industry was driven by marketing, really powerful industry groups, the breeding you mentioned, producing these big, gigantic, red, firm, transportable, non-perishable. And it's just striking those of us that have the opportunity to grow like a little plant, you know, the real taste of a strawberry often is quite different than what is done commercially now.
Absolutely.
If any of you have any questions, please come to a microphone. There's another great question here from Elliot Mack. Are you here tonight, Elliot? Come on over to the microphone and introduce yourself to Julie. Tell us what you're studying and give us your question.
Hi, my name is Elliot Mack. I'm a senior studying sustainable environmental design. My question was, given that soil diseases are on the rise and soilless systems provide the opportunity to grow fresh fruit year-round that does not have to be transported long distances, in what ways is it unethical to support hydroponic growing facilities? This is something you touched on earlier. Some would say that it is smarter to build vertically as it requires less land. Others would say that we should learn to be stewards of our soil and not damage the soil we already have. Yet, to me, it does not seem as though these high-tech facilities are hurting traditional agriculturists' abilities to farm on healthy soil. If anything, these systems diversify the food basket and help make our food system more resilient. How are these vertical farming factories bad for the environment, and do you oppose them? Some things are already covered.
Yeah, I've kind of covered that. I mean, I don't categorically oppose them. I am concerned about the labor conditions of strawberry production and other agricultural production, and there's no question that having vertical farming or even like waste trays would be much better for workers. I mean, strawberry work is the pits. And I wish I'd had the video because you could see people just racing bent over. So that's one of the reasons I'm attracted to vertical farming. I don't know that it's environmentally more sustainable. I mean, and this is true not only with, you know, fruit and vegetable production, but, you know, cellular meat, all these kind of new ideas. I mean, the infrastructure, the energy it would take to grow this stuff it's like a trade-off between what we have now, which uses toxic chemicals, which is not great, to something else. So I don't know that it's better, and I don't have the specific tools. My tools are about raising these sorts of issues.
I think what's challenging is it doesn't feel like certainly the government, the land planners, the regulators, nobody seems to be really like out in front of the technology. I often think about this as that we need something called the Department of Unintended Consequences.
Right.
You know, some people that can kind of look at a system, look at the scenarios, because you think about like who's deciding on land use now? Who's gonna do the zoning for vertical
farming, right?
Yeah. I mean, it's certainly, we have similar challenges with autonomous vehicles coming into communities.
Well, yeah.
Anyway.
Yeah, that's a good question. I mean, my impression is that, I mean, I know with cellular meat, the FDA and the USDA are not gonna get in the way of it, and in part because some of the big meat producers like Cargill and Tyson are already invested in it, and they know how to work it. And so, but I think generally the U.S. government, particularly the U.S. government under Trump, wants to encourage business. So they're opposed to kind of regulation. I don't know that I answered your question in its entirety, but
it's a tough question.
Yeah. Okay.
Did you find in your research that there was a lot of industry involvement in terms of managing the use of the pest or perpetuating the use of pesticides, or was that sort of a moot point?
In what industry?
I mean, I'm just saying, like chemical industries. Was there a lot? Was there lobbying? Was there?
People have asked me that. I did not see a lot of it. I mean, we do know that the way the chemical industry works is they have their own extension agents, and their own extension agents go and work with growers and encourage them to use particular chemicals. It's just not something I really looked at carefully. I should have, but I didn't. That exists. So I think that's how the lobbying happens, is that growers listen to whoever's going to give them good advice. And if somebody comes from, Arista Life Sciences, which is the one that was like methyl iodide, and Arista Life Sciences actually paid a few growers to do trials. And so those growers are going to be like, I'm going to adopt that. So that's how that happens. I think one of the things that's really interesting here is that companies like Driscoll's, and Driscoll's is pretty much the most powerful strawberry company. Now, what you need to know that you probably don't all know is that Driscoll's doesn't grow any of its own strawberries. Driscoll's supplies growers with, they have a major plant breeding operation, so they supply growers with breeds, and growers have to pay big licenses for these cultivars, and they have to purchase the Driscoll's shipping boxes, and they have to pay sales commissions to Driscoll's, and so Driscoll's supplies them with the marketing tools or the marketing material and the cultivars, and then does the marketing for them, but Driscoll's doesn't take any of the on-farm risk. And so Driscoll's was, Driscoll's and other buyers were not particularly encouraging growers to use methyl iodide. And Driscoll's is very much promoting organics and other kind of measures of sustainability, and Driscoll's also has a labor program where they want to encourage growers to have better labor practices. I don't really know what that looks like on the ground, but one of the issues is that Driscoll's doesn't have to take the risk, and this is a thing that I think many involved in the tech industry don't understand, is that farmers are taking all the risk, and selling them more stuff isn't going to make them more profitable. That makes them less profitable. And so, like, I think it's, if any of you are interested in tech that supports growers, you have to start talking to growers, because growers really they lose profits because they grow too much, and they lose profits because they're paying for supplies and they're being squeezed by buyers. So we really have to pay attention to the constraints that growers face in any of this.
It seems also that perhaps in strawberries that that variance between what a conventionally grown basket costs and what an organic is dramatic. I mean, it can be like twice as expensive. So that is one of the areas that people, focus on, saying organics are inaccessible. You talk about that in your paper too. That, this. How do we deal with this, that this ends up being like a delicacy? Right. I mean, after I read your papers, I was kind of like, wow, here's something that we've come to crave or, enjoy, and it's effectively built on a completely unsustainable foundation. I was thinking about, are my great-grandchildren ever going to even know a strawberry? Yeah. I mean, how do you, do you eat them still?
I do.
Yeah.
I eat.
You grow them, or you?
No, I can't grow anything.
Semper Vivium.
My family, we purchased strawberries from a grower who is the exception that it proves every rule. So this is this guy, Jim Cochran. He owns Swantonberry Farms. Anybody heard of Swantonberry Farms? He sells at the Berkeley Farmers Market. So he was the first grower to grow an organic strawberry, and he was the first grower to have a union label. So he has a UFW contract. So how does he do this? Well, he grows on conservation easement land, so he's not paying the full cost of land. He's using a strawberry varietal that no one else uses anymore. It's off patent, so he doesn't have to pay licensing fees for it. He has he grows away from the main strawberry regions, so he's not getting like kind of the infestations. He grows, he rotates with broccoli and cauliflower and artichokes, and he has different pieces of land that he leases, so he's actually rotating every 3 years. He can only do that because he has really low land costs, and he has a loyal group of customers that are willing to pay a lot for their strawberries. Like, they were like $5 a basket in off season. I mean, toward the tail ends of the season. So he's exception and proves every rule.
That's your way of participating in that system, in a way.
Yeah.
I mean,
Oh, his strawberries are delicious too.
Yeah.
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 Yeah. But I don't think that's the solution.
Yeah.
I mean, I don't think my ability to purchase my way toward better food is a solution. I mean, because that means, you know, I can afford to. But you know, if we want people who have low incomes to eat fresh fruits and vegetables, we have to find some other way to do it.
I heard about one approach down in Orange County where somebody was growing, I think it was our former Secretary of Agriculture in
A.G.
California.
Kawamura.
A.G. Kawamura.
He's
doing something kind of innovative, I guess. Or,
I don't know what he's doing with strawberries.
Okay.
I mean, he's involved in one of these privatized plant breeding deals, which is interesting, that the Secretary of Agriculture, he's one of the principals in one of these newly splintered private breeders. I don't know what he's doing. He might be doing anaerobic soil disinfestation. I'm not sure.
We'll have to try to get him here next semester.
Yeah.
Any other questions tonight? It's been a fascinating conversation. Really appreciate you being here. We're going to wrap up a little bit early tonight. I just wanted to let you know that next week we have pretty interesting conversation with Samin Nosrat and Shakira Simley, who are going to talk about diversity and inclusion in the food industry. If you haven't seen Samin's Netflix program, I highly recommend it. She's really a delight to watch discover new foods, and she's a Berkeley alum, so that'll be a great class. And for those of you that are students, stick around and we'll do Kahoot now. And for those of you that are at home watching on the live stream, we will say good night. And thank you again to Professor Julie Gutman.
Thank you.
Wonderful. Thank you.
Sure. Are our mics off?
Yeah, they'll turn them off here.